ACER came together to investigate the role of biological diversity as it influences the ecosystem's response to disturbance and how it provides resilience and resistance to that disturbance. And in this case, the disturbance we're talking about is the Deepwater Horizon event. So we've got 19 different scientists from 9 different institutions that are looking at biodiversity, and that would be diversity at the genetic level, at the species level, and at the functional level, and how that influences the ability of these ecosystems to respond to an insult, to some kind of disturbance that perturbs the system. And we kind of have a natural laboratory here at the Dauphin Island Sea Lab that includes large tanks where we can do studies. We can set up mini ecosystems and do studies to investigate how this biodiversity influences the response to oil pollution. We're sampling primarily in the Chandeleur Islands. The Chandeleur Islands are in Louisiana, and they're a really good place for us to investigate the effects of oil pollution because they were differentially oiled. So some of these islands received a heavy dose of oil, some a moderate dose, and some no oil at all. And the other good thing about this, from the perspective of doing science, is that there was very little cleanup work done on the Chandeleurs. This is primarily because it's a bird nesting site. And the thought was, we don't want to disturb the birds, it's better to let nature take its course. So we don't have this confounding effect of disturbance done by cleanup crews. We can kind of investigate the effects of oiling on the natural systems out there without that interference. One prediction that we might make, for example, is that higher genetic diversity provides resistance to disturbance. And we can then go out and look at some of these heavily oiled areas and look at the genetic diversity of the marsh plants, for example, that are there. And our prediction is that diversity would be higher in these areas that were heavily disturbed than in areas that were less disturbed. So that's one of the predictions that we can investigate as we go out there. Now, we also have the work being done in these large tanks that we have here at the Sea Lab, and that's to investigate on a smaller scale and a controlled situation where we're dosing with oil at a given level that we know, the concentration. And there we can also investigate the effect of genetic diversity and species diversity and this functional diversity as it influences the response of systems to oil. We can tell you by having gone out there and done some of this work in the field that there clearly is still oil out there. You can step on the sediments and an oily sheen rises to the surface. So these areas that were heavily oiled still have oil present 5 years down the road. And really that's one of the goals of this study, to look at what are some of the lingering and longer term effects that this oiling might have had. And we're focusing on some of the habitats that are really the most productive, the ones that really provide nursery for the finfish and shellfish, like the marsh habitats, like the oyster reefs, like the submerged vegetation or seagrass. So those are the habitats that we're really focusing on in our field studies. Somebody could ask, why study biological diversity? And the reason for this is because there's been quite a bit of work that's been done previously in the laboratory and a good bit of it done in fields on land that showed that higher diversity, and again, it could be genetic, it could be species, it could be functional diversity, provides a more efficient use of resources in the area, provides higher growth rates and higher productivity, especially in farm situations. There's been relatively little of this done in marine systems. In addition, most of it's been done on small scale. It's been done in the laboratory, in greenhouses. So we have an opportunity to test this biodiversity hypothesis, that is, that diversity provides resistance to disturbance and helps systems recover more rapidly when it's high, on a big scale. We're doing it in a marine environment where most of this work has not been done, and at a big scale. The Deepwater Horizon disaster was a big event. It was a huge disturbance. So this, we think, is really going to be a critical test of this general biodiversity hypothesis that people have talked about for the last 10 or 15 years.